Our next speaker and our last speaker is Slava. He's a data engineer at Zalando. Here he is. And you've heard about the data lake, you've heard about Nakadi, and now he's going to tell you about everything that's in between. There you go.
Hello. Okay, so I know it's very late and you're already tired, but bear with me. Just last 20 minutes. I promise they will be interesting. So I heard many of you are interested in data engineering, data processing, and different distributed stuff. So this is going to be quite a technical talk, so try to pay attention. I try to make it as entertaining as possible, but so I'm an engineer, so you can imagine. So just short outline, these are some of the things that will be covered to some extent. So I'm from Data Lake team, and obviously we'll be talking more about Data Lake. There will be something about Lambda, something about Spark, about Airflow. So like common tools for data engineering nowadays. Okay, so what problem we had in the data lake, in essence. So we want to have data in the data lake from the company, from all over the company basically, and then provide it in some ways to the company again in different ways. Yeah. So it's a sort of a sink for the whole data. And one of the use cases we have is Nakadi that you just listened about. As a messaging bus with roughly 2,700 event types at the moment, which basically I think you can map to Kafka topics, and with a total rate of 200 megabytes per second. So it's quite a lot, quite a lot of data going through. And yeah, the problem is how to have all of that in data lake in a timely manner, and yeah, that later provided. So yeah, as you see, Nakadi just a bus between all the microservices. Yeah, you already know that. And the initial implementation to solve this problem was very sort of naive and straightforward. We just created an application that we ran on EC2. Maybe first of all, could you raise your hands, those who work with cloud and like know some of the cloud concepts and experience? Okay, so more than half, I think. Very good. So we just ran on EC2 an application that was reading directly from Nakadi API and writing directly to an S3 bucket. And like, I think it cannot be easier than that. And obviously this had common problems of like manual running of applications and having like a monolithic applications that you need to operate everything. You need to operate CPU, memory, disk space. You have to manually add new event types that arrive at Nakadi, that are created at Nakadi every day. You have to manually add them every day, and so on and so forth, and it would fail because of various reasons, like low-level Unix reasons, and so it worked. It worked for some time, actually, for quite a long time, but it was always a big burden in terms of operations, in terms of scalability, and other reasons. And we decided maybe we should do something else, try something else. And actually, one other important reason, we had few bigger event types in Nakadi, which this application, it's called Diga, as you can see on the slide, it just couldn't handle them. They were too big and had too high rate of megabytes basically per second. And so we decided, okay, first of all, let's simplify the problem. Let's ask the guys that develop Nakadi to dump some data somehow in an easier way to somewhere, so that we can access then data at rest already and not access the API. And because the Nakadi guys, they have direct access to their infrastructure and they can change Nakadi and so on and so forth. For them, it's kind of easier. And they did that. The application that is called Nakadi Archiver, and it was dumping data in a very dumb manner just all the time to an S3 bucket in their AWS account. And this is right now it is like that. So, and then we decided to try Lambda, and this was one of the major initiatives, so to say. Let's try Lambda and see if it works. Lambda in recent years is quite a hype. And basically, we figured out that there is a nice way in S3 to configure so-called event. So when you write something to S3 or you delete something or whatever you do, you can configure an event happening, and this event can trigger Lambda. And basically, on each file that is getting written to S3, there is a Lambda function triggered. And this was very nice integration inside of AWS, which didn't require really so much of communication between teams either. And in this Lambda, we were just taking this file, basically every file that is getting dumped by an Arcadia archiver, and write into our bucket in a little bit different shape, but more or less the same file with the events inside. Archive, just an archive JSON gzip. Okay, this worked fine. Then there was an issue with how do we reprocess if Lambda code fails, and this can fail by multiple reasons. You can have some bug, or you can run out of memory because you obviously define some limitation on your Lambda function, or it can time out and so on and so forth. So, and we figured out there is a way to configure an SQS queue, so basically queue in AWS infrastructure, where metadata about those files that your Lambda failed to process will end up. And later you can do something with this. And to do with this, there was nothing to do with this. Basically, there was nothing prepared, predefined in AWS to handle this later. So it's just there. Your Lambda failed sometimes, and there is nothing to do. And we had to implement our own Spark application to basically repeat the work of Lambda for everything that ended up in the dead letter queue. So this queue is called dead letter queue. Well, so it worked, but then every time you would have an incident and like something started to fail and you have those messages in the letter queue, you have to go and run a script that would create, spin up an EMR cluster and like run a Spark job that would repeat everything your Lambda is doing. Yeah, it worked. Not very nice, but worked. Okay, so, but there was still one step missing. The data that we were writing by our famous Diga application in the top, we were still didn't reach the point of having the same functionality as before. We were still in the middle. And we came up with another Spark job that would just take every partition, basically every hour of data from like a raw bucket, how we call it, the one in the middle, and repartition it by the needed field, basically by the time of occurrence of event. That's the production bucket of data lake, how data is partitioned there. But here the problem is like who is running the Spark? It's just like you have a Spark job, but you can create a cluster, but who is triggering everything? And we decided to try Airflow. Okay, things are growing. We came up with a so-called DAG, or you can think of workflow, if, for example, you're familiar with Uzi. Basically just a small code that triggers a Spark job using Livy. Doesn't matter, basically triggers a Spark job in EMR cluster. And like every hour for each event type, there would be a separate job. Basically, we started with just, I think, maybe 1% of event types. Like we had 2,700 and we started with like 80 or maybe even less. And okay, it was working to some extent, but the problem was, no, not really the problem. The other thing, the 11 that you see here is we also wanted to sign the partitions that we write to the raw bucket with _success file, a common technique to say that, okay, this partition is complete. And then like we ran those two things in Airflow. For the write _success, we actually went for all like 2,700 event types. And it worked to some extent, yeah. And then there were problems. There were many problems with Airflow because we realized it just cannot handle all the scheduling. Because when you have like 2,700 sort of workers or like executions every hour, and then actually you need double of that because you need to create _success files, and then you need to trigger Spark jobs. And you need the later one to start after the first one, and like Airflow is nice for some machine learning, nice DAG where you have different steps that depend on each other and so on. But when you have this like very intensive low-level infrastructure and very trivial workflows, actually just cannot handle the scheduling because scheduler is just a single-threaded application in Python. Another major thing that was happening, it was I think July or so, that AWS released the integration between SQS, queues, and Lambda, which wasn't there when we started. And plus, we realized that if you look on the Spark on the right, so basically the very last step, the repartitioning by the needed field, we realized that this job didn't require any shuffling of data, and it was really trivial, like only mapper phase Spark job, which we somehow misunderstood in the beginning, or you can implement it in different ways, let's say it like that. And yeah, we started thinking maybe we just change everything. And so this is what we had. And the first thing we tried the integration between SQS and Lambda. And so in the middle you see the Spark disappeared, because the same dead letter queue now we were able to connect to the same Lambda. And it's really, you go to the UI and there is a button, enable connection, and it starts consuming from the SQS queue. And basically reprocessing from like a tedious Spark EMR job, which also costs, I think, more money, became very simple press of a button, which you can do in few seconds. And it worked very well. The next thing we wanted to try is to get rid of Spark, because we don't need shuffle, and we tried already approved technique of using SQS for the Lambda and just the Lambda instead of a Spark job. Because essentially for each file that arrives in a raw form, we just need to take it and write to the destination bucket to different partitions based on this keyword at field of every message, of every event. And again, this worked very well. So we had a nice integration, we had nice reprocessing in case of failures, and you can imagine everything was just running reactively without Spark. You have to monitor the progress of jobs and so on, and see that your yarn is fine and so on. So there was only one thing left, the creation of _success files in the middle bucket, in the raw bucket. And we decided, well, why don't we try again just try to do it with Lambda? And actually, the very nice thing that in AWS there is a cron, it's called cron rule, but basically you can have a cron event that you can schedule to run based on a cron string and trigger multiple things like Lambda, or like send a message to a queue or to a SNS topic. And basically we just implemented this fan-out mechanism with one Lambda triggering like 2700 other Lambdas for each event type to like write _success. And this was success. Basically, we got rid of all the EMR, Spark, Airflow, all the EC2 instances we were running manually, except yet for Tiga on the top, which was still running for most of event types. But here we proved that we can actually run the new pipeline for everything. And we just shut down the old, very first initial application. And we switched all the event types from that are in Akadi to go through the new pipeline. And the pipeline is completely sort of autonomous. And also because you can see this long line 13 that we also list event types in Akadi. It doesn't need anymore to manually add event types to the pipeline when there are new event types in Akadi. So basically now it just runs, and most of the time we don't have any problems. Sometimes we have, but they're usually trivially fixed. The very last thing we did, we also implemented the pattern of the queue in front of the very first Lambda, just to be more flexible in processing if we want to change it, basically to decouple from the other team's account. Because events that the S3 bucket is creating, they are configured by the Aruha team working on Akadi. That's it. Basically, this was the fully serverless pipeline. What we have learned, so the major thing, serverless is really great. It works very well when you integrate serverless services, at least in an AWS. They are very stable, and the experience in general is very nice. Operations are much easier than when you run something in virtual machines, even on Docker or whatever. We also learned that you should monitor new features and new technologies, because we didn't know about this integration with SQS, Lambda and SQS, and those things, they can change the game, really. Another thing was, this is always a question, streaming or batch, and initially we have this processing of partitions, of hourly partitions. Now everything is reactive, and we really like it much more, because this opens the doors for much faster features that can provide data much faster. It opens doors for very short latencies and to like micro batching and different types of streaming. Another thing, just in terms of the process, iterate. I think the very good thing that we happened to do was that we iterated, we tried different approaches, we failed, but then we tried something else, and we never tried the waterfall, like let's design the beautiful, perfect architecture and then just implement it, but we constantly were rethinking everything we are doing, and I think it worked well. And use right tools and not just cool tools. Although we all like Spark and Airflow very much in the department and we want to use them for other things, but here we just proved by doing that they were not needed, and even Airflow was really not the good fit for the job. I think that's it. I hope you liked it.
And oh, there's already a question. Excellent.
So I want to go back to the initial problem. Maybe I misunderstood. Do you do any kind of transformation when you want to write your raw events to S3? Or is it just, why don't you go with like any kind of Kafka connector which works with distributed file systems, whatnot?
Yeah, sorry. So basically, in essence, we want the data be in a raw format as it just comes from Nakadi or from other sources, because we want to provide schema on read and like allow and enable other teams to put schema on top of the data and not say them that this has this schema, so they can decide. The only real difference is that you can read here that it's written partitioned by time of events. So every event has sort of time when it goes through Nakadi and comes to the data lake, sort of ingestion time, and it has the cure time, some time when it happens somewhere in the system of the team that produced it. And historically, data lake was created with the idea to have data lake partitioned by time of cured. So this is the only transformation we're actually doing, and we don't do anything else, no aggregations, no nothing. For this part, for this use case, yes. And answering about Kafka, I think this was sort of implementation of what you are talking about first. I cannot really answer why, for example, Kafka wasn't chosen to do this. This was chosen, and yeah, who knows now.
As I understand that you built a truly serverless data streaming pipeline. So from the DevOps perspective, what kind of metrics you monitor to observe how your pipeline is performing?
So we have different SLOs. Mostly they are about latency of propagation of data. And basically we monitor in those, how long it takes since data arrives in the bucket of the other team yet, on the source bucket, and how long it takes it to propagate to the first bucket and then to actual data lake bucket. We also obviously monitor different like technical measures, like different numbers about number of invocations of lambdas, number of messages in the dead letter queues, average and like different quantile of durations of lambdas and so on. But the critical ones which we're using also for the like on-call thing, the latencies, SLOs. Yeah.
Yep.
Would be interesting to know what was actually the issue with the Airflow scheduler. Like, was it crashing?
Can you say into the thing?
Yeah, would be interesting to know what was the issue with the Airflow scheduler. Like, was it crashing?
Yes, so we went through a very interesting journey with Airflow, so we can consider ourselves now experts of Airflow, although we're not using it anymore. Sorry. The thing was that Airflow has quite an architecture on its own. So there are three types of applications. So one of them is scheduler, Plus there is a database and there is like Redis for the queue and those things. So the scheduler is a bottleneck just because it's a single threaded Python application and it has to handle all the DAGs or all the workflows you have defined. So if you have just some, it's fine, you will not notice it. But as soon as you start growing, and we had out of the box 2,700 and plus already initially multiplied by 2 every hour, although they were completely trivial, so Scale just couldn't handle that. We tried the biggest instances and with best hard drives in AWS, and this still didn't solve the problem. We almost implemented multi-scalar approach, but unfortunately Scalar is doing some tricky things with database, and they were just interfering with the rows of each other, and it wasn't possible. So yeah, it fits better for the cases when you have complex workflows, but not many workflows.
Any more questions? Yes.
I basically have 2 questions. The first one is, have you considered cross-region replication from one S3 bucket to another one?
So we consider it, and we even have it, and we suffer from it. And so this is the answer. Do you have?
What kind of suffer?
So first of all, money. When you have like terabytes of data arriving every day, you pay twice, and you don't. So the S3 provides various features. So it has life cycle and different levels of durability and accessibility. Then it has cross-region replication. Then it has policies and so on. So you can do multiple things to sort of save your data from like accidental deletion or from malicious attack or something like that. And it has versioning. So we also use versioning. So if I just go and delete now or something, it's not really gone. We can recover it. So initially, I think it was done, but then we realized we just spending money, but we don't really benefit from it. And also, we had some incidents trying to like migrate to Glacier. So better not migrate to Glacier if you're not sure what you're doing. Seriously.
Okay, cool. And the second question is, what was the most common reason that your messages end up in dead letter queue? I mean that you're writing S3 objects inside AWS data center, the network should be more or less stable, right?
Yes, that's a very good question. There can be different reasons. So first of all, if you have just a bug in your code, or not a bug, you don't cover some corner case. So you can have an exception. That's the simplest, I think, and simplest to fix. Because you just fix, you deploy, and you connect your dead letter queue to the Lambda in this case, and it just reprocesses. Very simple. Today we had a very funny day when we saw multiple messages in dead letter queue, and after some minutes we just tried to reprocess, and everything was reprocessed successfully. So this was either something we haven't understood yet. Maybe there was some memory limit reached, for example. That can be one reason, or timeout, because there is a hard timeout of 5 minutes, and we had like 1, I think, until now. But also, I think it just sometimes can be some AWS underneath infrastructure hiccup. And we saw once that suddenly, instead of having like roughly 10 to 20 messages in the input queue, in this one on the left bottom, which is like normal state because everything is getting processed by Lambda all the time. And once we saw just 3,000, and then like after 10 minutes, we saw again 10 to 20. And like we have no control over it, and like 99% of the time, like I think 99 point something, it just works out of the box perfectly and scales out, and you don't have to think about it at all. But sometimes, yeah, there are those things. So I would say good configuration, understanding of your use case, what kind of data you're processing in your Lambda is important to not have too many failures. More or less, that's it, yeah, and unit tests.
Thank you.
Questions? There's a question over there.
Here on the left.
I'm going to try to throw it without You know what? I'm just going to pass it to you. It's too many beer glasses there.
It's not a question. Can I like comment on it, Slava? Maybe to one. So
Sure.
to comment on the first question about why not just like dump Kafka directly to S3. Essentially, this is what is in a way happening in the archiver. But what is so? First of all, this is not Kafka. This is something around Kafka. Akadi is something like a layer around it. And then the second thing is that the data is not in the format that we then require in terms of the internal structure. So this initial dump is there to secure the archiving of the data, but it is not usable for use like in like further in the data lake. So in this case, we actually have this kind of like quick dumping of everything that is happening in Akadi, and then we have this like buffer of 30 days to actually process everything and transform it into a form that is usable for the users of the data lake. And to comment on the question about why not replicate across region, because we are actually trying to keep every application in the same region. What is happening here is a copy and transformation between two AWS accounts. However, we try to keep everything in one region because it saves cost on data transfers and everything else. So you can use replication for backup. However, this is not our use case. We need to transform, we need to make sure that we also don't replicate operations like delete, for example, which would be pretty bad.
Thank you.
Thank you. Any more? The last question? Well, that's it. Thank you again. It's